Hey guys, it's Miss Marflack here. We're gonna take a look at graphing cotangent today. This is a really exciting time because this is the last thing that we have to do in trigonometry. So after we do this video, it's kind of gonna conclude our whole segment that we've been working on trigonometry from September. And then after this, we're gonna start with the Algebra 2 review, and then we're gonna finish off the year with an introduction to calculus. So this is once again the last thing that we're doing in trigonometry, and that's gonna be graphing our cotangent graph. Now, it's really important that you stick around for this whole video and that maybe you watch it more than once, maybe you watch it 2 times or 3 times, because A, we're having an upcoming test, yeah, that's important, and then B, we're only spending 1 day on cotangent. So cotangent is very similar to tangent, just like cosecant and secant are phase shifts of each other. So there is no need for us to spend multiple days on cotangent. So we're spending 1 day on cotangent. So in this video, we're going to do the parent function. We're going to take a look at cotangent with A and B transformations, C and D transformations, all of them together, and a negative. So we do have a lot going on today. All right, if you need a quick refresher, our cotangents are reciprocal of tangent, and since tangent is y over x when we're looking at quadrantals, our cotangent is x over y when we're looking at quadrantals. Good thing I put our little unit circle over here, and we're going to start off with our planned table of values. I chose the values from 0 to 2 pi. We have quadrantals, and we also have the pi over 4s in here. All right, so make sure you have this chart down. We're starting with this first x value. We're plugging it in. We're evaluating cotangent at 0. And at 0, that's going to be y over x. I mean, not y over x. X over y, that's going to be 1 over 0, and that's going to be undefined. And then now pi over 4 is in quadrant 1. Cotangent of pi over 4 is positive 1. All right, positive because it's in quadrant 1. All right, now pi over 2, that's going to be x over y. 0 divided by 1 is 0. We're in quadrant 2, where cotangent is negative. Its reference angle is pi over 4, and cotangent of pi over 4 is 1. Here we are at pi. We're going to do x over y again. Negative 1 divided by 0, and that's going to be another undefined for us. Here we are, 5 pi over 4. That's going to be in quadrant 3, where cotangent is positive. Reference is pi over 4, and there we are. Our answer is 1. And then 3 pi over 2, x divided by y. 0 divided by negative 1 is going to be 0. And then here we are, almost done, in quadrant 4, where cotangent is negative, and this answer will be negative 1. And then lastly, exactly where we started at 0, here we are at 2 pi, x over y, 1 over 0, and that's going to be undefined. So we're going to start our sketch here, doing our rough sketch of our cotangent graph. I'm not going to put in the negatives, but these are periodic functions that go on and on and on forever. We have our 0. I'm going to put my pi over 4 here, pi over 2, just listing out that x-axis, trying to keep that spacing as even as possible. 3 pi over 2, 7 pi over 4, and then here's the last one, 2 pi. All right, and then we're just going between these points, 1, 0, negative 1, and undefined. We have our vertical asymptote undefined at 0. We're also undefined at pi. We're undefined at 2 pi. All right, Miss Marflack's not setting a very good example here, but you should have arrows at the end of your asymptotes. Maybe I should put those in there. I'm going to put them in. All right, you should have arrows there at the end of your vertical asymptotes. A lot of you guys are submitting work without vertical asymptotes. The vertical asymptotes are part of the graph, so I really need to see that there. All right, and then now we're just plotting the points from the chart. So we have pi over 4, 1, pi over 2, 0, 3 pi over 4, negative 1. And then we kind of have that same shape over here. All right, so comparing our cotangent graph to our tangent graph, we should be noticing a few things. We should notice that they both have those vertical asymptotes. Even though they're in different places, both of them still have the vertical asymptotes. And then our tangent graph goes low, mid, high, and now our cotangent graph is going high, mid, low. Just kind of switching here and taking a look at what we have in the textbook. Some other characteristics of our cotangent graph is our period. We can see from the sketch that we did together that our period is pi, just like our tangent. Our domain is all real numbers except our multiples of pi. Okay, any multiple whole number of pi, you're going to have an asymptote even or odd. Our range is all real numbers because we have those arrows off to the end. And then that's about it. Here's our function. All right, and then for graphing, we're going to use the same method we've been using together in class. There really should be a plus D here. We'll take a look at that in a minute, but this is the key here. There is where now our asymptotes are lying, and then once again, we're going high, mid, and low. All right, now kind of preparing for that test that we're going to see, you have to keep in mind that we're doing all this remote learning, so the test, I can't ask you really to graph stuff from scratch. Instead, most of these things are going to be multiple choice, so it's really important to know these key characteristics, and we're going to move down here and just really quickly compare our tangent graph to our cotangent graph. And then those of you who are watching the videos will be rewarded with getting, a lot of these answers correct on our upcoming test. And you can definitely see a question where I give you a function and I simply ask you where the asymptotes are. And then our asymptotes for our tangent graph is between negative pi over 2. We have that bx minus c in the middle, and then pi over 2. And then to contrast over here, our cotangent graph is like a phase shift of our tangent graph. And then we're starting at 0. You could see that first asymptote. We have that bx minus c, and then we're going all the way to pi. And then once again, our tangent graph goes low, mid, high. There's our shape, and then our cotangent graph goes high, mid, low. And then these shapes do reflect when we do have a negative in front, but that's what it's like when we don't have a negative in front. All right, so once again, this is super important. This is definitely something to kind of box in your notes, keeping in mind that that test will have to be open notes. So this is very, very, very important. All right, now we're going to take a look at some examples. We're really going to do, let's see how many I got here for you. We're doing 3 examples, and then after 3 examples, you should be pretty much good to go with this graph here. All right, taking a look at the first one, we're just going to start off with an A and a B. That's usually the way we like to do things, and we're easing in, and here we are, no phase shifts and no vertical shifts. So we have 3 cotangent of 2x. All right, we start off the same way, listing out all those variables. I know we're probably so tired and bored of doing graphing by now, the same process over and over again. I said it would pay off. Hopefully you're really comfortable with this. And then we're going to be done with graphing after this. So that's something to look forward to. All right, our period is our pi over b still. So our pi and then our b here is 2. And then now when we're looking at those asymptotes, the asymptotes are in a different place than the tangent graph. All right, it's from 0 to pi. So I'm starting off, this is going to be like my starting point, and this is going to be my end point for one period. Keeping in mind that you have to solve for that x in the middle. So here I have to divide by 2, and that compound inequality, I'm doing that division by 2 on both sides. And then that'll leave me with just my x in the middle, and we can see that this function is going between 0 and pi over 2. All right, and then calculating our quarters is the same way. We still have these 5 key characteristics: asymptote, point, asymptote. So we're still taking that full period and dividing it by 4. When you do your keep, change, flip here, you're going to see that each quarter is going to be pi over 8. And then lastly, we want to solve for that low point, that midpoint, and that high point. We're going to see our midpoint is here at our y equals d. We're going to add our amplitude for our high point, and then we're going to subtract our amplitude for our low point. All right, and then now it's time to sketch, taking a look at our starting point at 0, and then we're going all the way to pi over 2. All right, so I don't need anything to the left of my y-axis. I just need everything to the right. All right, now dropping in, I'll do 1, 2, 3, 1, 2, negative 3, and starting my first asymptote is going to be here at 0. All right, my next point, I'm adding my quarter, which is pi over 8. I'm adding my next quarter, so that's going to be 2 pi over 8, which is pi over 4. I'm going to have 3 pi over 8, and then lastly, I'm going to have 4 pi over 8, which is going to be pi over 2. Keeping in mind, once it goes on the x-axis, it does need to be simplified fully, dropping in those vertical asymptotes here. And then now we're just following the shape of the cotangent function. Cotangent is positive in this example, which means that we're starting up at the high, we're going down to the mid, and then we're going down to the low. And then you can see it just looks like a reflected tangent graph with the vertical asymptotes in a different place. Now would be a good time to pause before we move on to our next example, which is going to be number 2, and we're going to have a C and D transformation, C and D. All right, after this one, we only have one more. And here we are, 2. We're going to graph y equals cotangent x minus pi over 3 plus 1. All right, so we're looking to graph, which means, you guessed it, we're listing out all those variables, a, b. Now, our minus sign is in the formula. I've said that 1,000 times, but it is, which means that c is positive. And then we have our d. Looking for that period is going to be pi over b, and b in this example is 1. Taking a look at those vertical asymptotes, we're taking everything inside parentheses, the bx minus c, and we're setting that between 0 and pi for cotangent, and negative pi over 2 and pi over 2 for tangent. And then now our goal is to solve for that x that's in the middle, which means I have to add pi over 3 to get the x by itself, and I got to do that to both sides here. So I'm going to add pi over 3, and I'm going to add pi over 3, which means I'm going to have pi over 3 on the left-hand side. We're going to have x by itself in the middle, which is what we wanted, and then we're going to have 4 pi over 3. Our quarters, we're taking that full period and dividing it by the 4 spaces between each key characteristic. And then lastly, we're going to solve for those lines here. We're going to do our midline, which is y equals d. We're going to do that high line, which means we're adding the amplitude, and we're going to do that low line, which means we're subtracting the amplitude. So you can see here we have a vertical shift up, and we also have a horizontal shift right. All right, now it's time to graph. We need all of our graph on our right side, and then we need some more space kind of up on top. So I got the 1 here, and I got the 2. And then our first point here is going to be pi over 3. And then now when we're adding our quarters are pi over 4. So if you want, you can do the addition off to the side. If you're not good with doing it in your head, that's okay. But this is going to be like 4 pi over 12 plus 3 pi over 12, and that's going to be 7 pi over 12. And then we're adding another 3 pi over 12. That's going to be 10 over 12, which is 5 over 6. And then we're adding another 3 over 12, so that'll be 13 over 12. Another 3 will be 16 over 12, and then that's going to be our 4 over 3. All right, so if you're not comfortable with that, that's okay. Kind of go off to the side and make sure you do this addition. All right, now it's time to put in those vertical asymptotes. Our first one's here at pi over 3. Our last one here is at 4 pi over 3. We still have a positive cotangent, which means I'm starting up at the high. I'm going to my mid now, and then to my low. High, mid, low. And then we get really close to the asymptote, we flatten out a bit, and we get really, really close to the asymptote. And there is our cotangent graph. All right, make sure you have this all down because we're going to move on here to our last example in the video, and we're going to add in now all, all these transformations, and we're going to have a negative. So we got negative 4 cotangent 2x plus pi minus 1. All right, this is where the process that we've been doing really pays off because it may look like a lot, but if you keep going with the same process, you will be fine. And that's what's starting out by listing out all of our variables. Keeping in mind that our A is the absolute value, our B, C, we have to take our opposite sign on the inside, and there's that D, that minus 1. All right, our period is going to be now pi over b, so that's going to be pi over 2. And then now we're taking everything inside parentheses and we're setting it between 0 and pi. Now, if it was a tangent graph, we would set it between negative pi over 2 and positive pi over 2. Solving for that x that's on the inside, I need to do my inverse operation. So first I'm going to subtract pi. All right, if you can do this in one step, go for it. For those of you who can't, that's okay. Miss Marfleck's doing it here in 2 steps. Subtracting pi from both sides, and then we're going ahead and keep isolating that x by dividing by 2. And we're going to see that our first asymptote is going to be at negative pi over 2, and then our last asymptote for one period is going to be at 0. We still have those quarters, which is our full period, divided by 4, and you're going to see each quarter here is pi over 8. Our midline, or our midpoint, is going to be at y equals d. Our high point, we're going to add that amplitude. So I'm going to add 4, and I'm going to get a positive 3 here. And then I'm going to squeeze this in down here. Is it on the video? Yes, it is. Low point, I subtract my 4, and I get my negative 5. Negative 5 there. Okay, now it's time to graph. Our whole graph is going to be on the left-hand side. So I'm not going to put that y-axis in yet, but I'm going to start at negative pi over 2, my first asymptote. And then our distance between each point is pi over 8. So this is like negative 4 over 8 plus 1 over 8. It'll give us negative 3 over 8. Plus another 1 over 8 will give us negative 2 over 8. Plus another 1 over 8 will give us negative 1 over 8. And then plus another 1, that'll give us 0. And there's where that y-axis is, okay? There's where that y, ooh, that's really crooked. That's okay though. There's that y-axis. All right, and then now it's time to put in our lines here, and we have our high line at 3, 1, 2, 3, our midline at negative 1, and our low at negative 5, 2, 3, 4, and here we are, negative 5. All right, dropping in that vertical asymptote, dropping in that other vertical asymptote on our y-axis. And now normally we go high, mid, low, all right, but keeping in mind this is a negative, so it's been reflected over the x-axis, which means we start at the low, we go mid, and then we go high. Low, mid, high. And then now it kind of looks like a tangent graph. All right. So this is the only video I'm doing for cotangent, and we're only spending 1 day on cotangent. So if this was like really confusing, you need to watch this video again, and you need to start studying for your test. If you have any questions, please email me. I'll be happy to do, some more videos on an individual basis if anybody is struggling with maybe like a specific aspect to graphing. All right, thanks for sticking in for the whole video. Make sure you do your homework and upload it to Google Classroom. Bye, guys.